Welcome to this channel. Today we'll solve Leetcode 968, which is binary tree cameras. So in this problem, we have given a binary tree and we need to install cameras in some of the nodes in this binary tree such the way that it can cover all the tree. If we install a camera at a particular node, it can cover its parent and both the children. And yeah, we need to return the minimum number of camera. For example, this tree, if we install camera at this node, then it can cover all the nodes in this tree. Similarly, in example 2, we need two cameras, and if you install like this, then it can cover all the nodes in this tree. So for this example 2, answer would be 2. Let's think about some solution for this. So if you look at the problem, we have a tree and we need to place some camera into it. So simple solution comes to my mind is just you can try for whether we need to place a camera into particular node or not. There is only two choice, and in this way find the minimum number of camera requirement when it can cover the complete. Let me draw the simple tree over here. So let's say if this is the tree, okay, so where all the camera needed so that it can cover all the tree. Let's say if I place the camera over here, it can cover all of these nodes, right? And then there is only single node which is not covered, so we have to place camera over here as well. So in this case, two cameras is needed. So what we can do is, simple solution is, we can create a pattern. What the pattern will represent, let's create an array of size n. In this array, for each element of this array would be either 0 or 1. What this represent, whether there is camera onto that node or not. Let's say into this node, 0th node, if you have no camera, but at the first node there is a camera and there is no other camera at any other node, then this will be a pattern. Then for this pattern, we need to check whether this can cover all the nodes in the given tree or not. To do that, we have to do traversal. Any of tree traversal we can do, and with this pattern we can check whether the tree, all the nodes in the tree is covered or not. And how many such pattern would be possible? So if you look at the array length is n, and for each element we have two possibilities, right? So total number of pattern would be 2 power n, and for each pattern we need to do a traversal which is taking n time. So for this case the time complexity would be this one. And what is the space complexity? So here, let's say if you want to implement this, then if you use this array and use some traversal, then there is first step is you need to generate all such pattern. In order to generate that, we have to use recursion. So there would be some function similar to, like, it will start with index n and we have total n number. Then the first index either you can replace with 0 or 1. So if you replace with 0, then you will call 1 comma n, and again if you replace 1 as well, then again you will call it 1 comma n only, but this particular array would be modified in this case. So you can take this global array and keep on modifying the elements and then calling the function. Similarly over here as well. So with this tree you can generate all such pattern. So what is the space requirement for this recursion? So this recursion depth would be n, right? So space requirement for this function call would be n. And along with that we are taking one global array which is also taking n space. So total space would be O of n. Here one more component will be there. When you are doing traversal, that will also take n time only, but overall time complexity will be O of n only. So if you look at the time complexity, it seems exponential, right? Just think how we can optimize it. Let's say we have this tree. Then just think about this particular node. So let's say there is no camera on this node. So how you can cover this node? Either it can be covered by its children, either it can be covered by its parent. So what are the conditions when we need to place camera over here? So if you reach over here and then let's say these children are not covered. Let's say there is no camera over here, no camera over here. So in order to cover these two, we have to place camera over here. So the first condition is when no cameras on children. The second condition is either this condition will happen, then we have to place camera over here. Either let's say the second condition, let's say I'm moving here. So let's say this node, I'm focusing on this node now. So for this node, to cover this node, if there is no camera on its children, that is the only way this node is not being covered. So, and let's say there is no parent for this node. So a node can be covered either by the parent, either by the children. So let's say on children, from children it's not being covered, right? So, and there is no parent for this node. Then we have to place camera over here, because if you place the camera over here, then only this particular node will be covered. In this example, this node is already covered, this node is already covered, this node is already covered, and let's say there is a camera over here, so this node is already covered. So the only node which is not covered is this one. So no, if you place camera over here, it will be covered. Let's assume there is one more node over here and there is a camera over here. So in this tree, all the nodes are covered except the root node. So we have to place the camera at the root node because there is no parent for this node. If there is a parent, there is a possibility that it can be covered from there. So if there is no parent, then also we need to place the camera over here. So in this approach, what we are doing is we are checking for these two conditions to happen. When any of these two conditions happen, we directly place the camera over here. Because if you don't place in these two conditions, then there is no way to cover it. So what we can do is we can use post-order traversal here. Why post-order traversal? Because if you use post-order, then only we know that its left subtree is covered or not, right subtree is covered or not. So we use post-order traversal, and whenever it reaches to some particular node, we'll decide whether we need to place the camera or not. If you need to place the camera, we'll update the count of the camera. And how to know whether the left subtree is covered or right subtree is covered or not? We can create some kind of hash map, right, which is like something tree node, and whether this is covered or not. So we can take some boolean. So with the help of this, we will be able to know whether the left child or right child is covered or not. So what is the time and space complexity for this? So let's talk about time complexity first. So what we are doing is we are doing the post-order traversal, and in the post-order traversal, depending on these two conditions, we either place the camera or don't. So placing the camera means just updating this hash map as well as updating the count. So post-order traversal will take O of n time. And let's talk about space complexity. In space complexity, as we are using post-order traversal, so it will take O of n time, n space, because that is a recursion space in case of the tree is skewed, and there is some space requirement for the hash map also. So in hash map also, the total number of nodes we can add at max would be n only. So the space requirement will be O of n. Let me quickly go through the solution for this as well. So what I did is I just created a hash set called covered, and I called the post order for this route. And in post order, this is the basic condition. Then in post order, first we visit the left subtree, then we visit the right subtree, and after that I'm checking these two conditions. First condition is whether the left child is not covered or right child is not covered. So if both the children is not covered, right, either the left subtree is not covered, either the right subtree is not covered. So in that case, there is no other way to cover them rather than putting the uh, camera at the road, right? So if I am at particular route, then if left subtree and right subtree, because it's a post order traversal, so they are not yet covered. So that the only way we can cover is with the help of putting camera onto the root node. So in this case, we can place the camera onto the root node. And other case would be if there is no parent for a particular node and that particular node is not covered, then also we have to just increase the number of camera requirement and update the covered hash set. So in covered hash set, we are basically saying that if you place a camera into a particular node, then that particular node, its left child, its right child, and its parent, all of these four nodes will be covered. Okay. Let's think about some other solutions. So we are not thinking about optimizing this solution, just the another way to solve this similar problem. What we can do is I'll take the same tree, say like this, and we can define three kind of subtrees, three states basically of the subtree. Let's say it's called S0, S1 and S2. What does S0 means? If you are at particular node n, so if a tree rooted at n, S0 means all the nodes are covered except this particular node n. So if we are talking about this particular node, it means that all the remaining nodes are being covered with some cameras somehow, but this particular node is not covered. So here we can say that all except root. So we can define another state. This state will say that all the nodes are covered, right? All the nodes are covered and there is no camera at root. So the second case is in this tree all the nodes are covered but there is no camera over here on this particular. The third case is all the nodes are covered and there is a camera at root. These are the three kind of subtree can be possible considering a particular tree rooted at any node, right? So with the help of these three states, we can solve the problem. How we can solve the problem is, let's see. We know these three values, right? Let's think about this particular tree, and you are at here, and you know S0, S1, and S2. Then what would be the answer for this tree? So what is the purpose of this question? We need to cover all the nodes. So these are the two cases which says that all the nodes are covered. Okay, these are the two cases S1 and S2 which says that all the nodes are covered. So we have to find the minimum number of camera needed in any of these steps. So the answer would be minimum of S1 comma S2. Let's see how we are going to update these things. So what we can do here is we can again use the post order traversal. Post order traversal only. Reason being, in tree we use the post order traversal because if you wanted to compute the left subtree and right subtree and then only decide about the root, what would be the answer for it? Because here we have to cover all the cameras, all the root node with the help of camera, so we will be able to know whether the particular subtree rooted at particular node is covered or not only if we have already visited the left subtree and right subtree. That's the reason we are going with the post order. So I'm just going to quickly tell how we compute the S1, S0, S1 and S2 for any particular node. So let me draw tree again. So let's say I'm at here. What will be the value of this post order will return three things, right? It will create return three values, an array of three values, S0, S1 and S2. So if I'm at this particular node, then I have values from the left subtree as well as right subtree. Let me just explain the simple tree. I have this. So if I'm at this particular node, then I have values from left subtree as well as right subtree. Let's just write L0, L1 and L2, and here let's say R0, R1 and R2. So how we can update values from here? Let's say what would be the value of S0 here? S0 says that all the nodes being covered except this particular node. So what are the cases says that all the nodes being covered? So here all the nodes covered means what? This left subtree has to be covered. So L1 and L2 will says that this subtree is covered and this particular node is also covered. L0 says this has been covered, but all the subtree rooted at this is covered, but there is no camera at here. So S0 means this complete subtree is covered except this particular node. So we can't place camera either here because if you place the camera here, this node will be covered. So in L1 and L2, the camera will be this particular node will be covered. Okay, so what would be the S0? Okay, so S0 will be what the S0 represent is this particular node should not be covered. So we can't place camera over here, can't place camera over here. So L2 and R2 won't be the possible number. So just think about the left subtree only. So L2 won't be possible. Can we consider L1? L1 says that all the node covered, all the node rooted at this particular node is covered, right? And there is no camera here. But L0 says this is not covered, so we can't use L0 here, only we can use L1. And from here we can use R1. So the answer for S0 will be this one. Similarly, let's think about S1. So what S1 says, all the nodes being covered, but there is no camera over here, this particular one. So all the nodes has to be covered. So this particular node will be covered if there is a camera either here, because here we were not considering the camera. So if there is a camera on left subtree, then what are the possibilities? Either we can take, let's say we are considering there is a camera at node and the left subtree, so it will be L2 if there is a camera and all the tree will be covered, plus in the right side there is a possibility either we can take the camera, either we can't. So we can take minimum of, either we can, so if you take the camera it will be R1 or R2, right? Other case would be, let's say we take cameras on right side, so it will be R2 plus min of L1 comma L2. Okay, let's see how to compute S2 here. So what does S2 means? We have to place the camera at the root over here. Then there will be one camera needed plus. Now, if you place the camera at root, these three nodes are already been covered. Then what would be the what we can take? L0, L1, L2, anything, right? Because even if you take L0, it means it says that all the subtree rooted at this node is covered, but there is no camera. All the nodes are been covered except this node. So this node is already covered by the root. So L0 also we can take, similarly L1 and L2 as well, because in L1 and L2 all the subtree rooted at this node is covered. So this will be min of L0, L1, L2 plus min of R0, R1 and R2. You can take any of these numbers such that the total camera requirement is minimum. So if you know S1, S2 and S3 for all the nodes, then we know that what is the answer, which is this one. Now let's talk about the time and space complexity for this solution. So in time, what we are doing is we are effectively doing a post-direct reversal and doing some constant amount of computation. So the time complexity would be O of n. And then what is the space complexity? Yes, we are doing post-direct reversal. In worst case, it might be skewed. So stack requirement would be n. So the space complexity would be O of n in this case. So time and space both are O of n. Let's go through the solution quickly. So here what I have done is there is a method called min camera cover. So I have written on post order method. This post order will represent three things: S0, S1 and S2 that I have explained. So this is just the case when there is no node, right? And then for the left subtree we need to call and right subtree call as per the post order rule. And then these are the two temporary variables I created, so that this represent that left subtree is being covered. Then what is the minimum requirement? So left subtree will be covered in the two way, right? Then we can place the camera at that root or not. Similarly for the right subtree as well. So here let's update these values S0, S1 and S2 that I have already explained. And if you know all these values, and then return the value. So finally, if you have S0, S1 and S2, our answer would be S1 and S2, because these are the two states when all the nodes being covered. Okay. Thanks for watching. If you have any query, suggestions, just write into the comment section.